course. Alright, zero exponent property, class. Alright, this one just says that whenever you raise anything to the 0 power, what do we get for the answer?
1.
Right, so a to the 0 power equals 1. Okay, anything raised to 0 power
Just becomes.
Okay. Okay, the only thing that's undefined is if you try to raise 0 to 0 power. Okay, that's the only thing that's undefined. Alright, so let's go ahead and try a couple of them. Obviously this is no matter what, watch. 3 to 0 power, class, is what?
1.
1, okay? 7xy to the 0 power.
1.
Let's talk about why this is the case. I don't want you to say 1. I want you to understand why is it 1. Watch. Guys, what if this was just any power, what would I do to everything inside of this?
Raise it to that
Raise the power outside of it, right? Using the power of a product property. Watch what I do. 7 to the what?
0.
0 times x to the 0 times what? Y to the 0. Here's why it becomes 1. What is 7 to 0 power? 1. What's x to 0 power? 1. What's y to 0 power?
1.
What's 1 times 1 times 1?
1.
That's why it does not make a difference what you raise to 0 power. But let me do something though. What if I do this though? What's that answer going to be?
1.
Stephen?
1 times 3 to the 3rd power.
Good. Notice he just didn't say 1. Yes, this is 1. 7 to 0 power becomes what?
1.
1, but we have to simplify 3 to the 3rd.
27.
27. 3 to the 3rd is 3 times 3 times 3, which is 27. So what is my actual answer?
27.
27, right. So when you start thinking about doing this, you have to understand that, pay attention, if it's all inside the parentheses and a zero's outside, then the whole thing would be a product of 1. But we have to understand that when there's multiplying by some other base, that it will be simplified using 7 to 0 power, which would be the 1, but not the other one, okay? All right, let's try a couple other ones here. Just going to kind of combine all this together. All right, and then we'll be done. How about this one? Example 4. We got 2 more to do, guys, and we'll be done. Thank you for being patient. All right, 3 to the negative second times 5 over 7 to the 0 power. A little different looking. What do we need to do to the 3 to the negative second power? Does everybody agree we need to rewrite that as what? 1 over 3 to the second. So let's rewrite that as 1 over 3 to the second times, and then what do we do with the 5 over 7 to 0? 5 stays exactly as it. There's nothing outside here, is there? So we can just rewrite 5, but what does the 7 to 0 power become?
1.
A 1, exactly. Now we need to simplify. What does 1 times 5 become what?
5.
5. What does 3 squared become? 9. So let's just cross it up with a 9 in place. What's 9 times 1?
9.
So our answer is
5.
5 nines. Good. A little different looking, okay? But again, as long as you understand the negative exponent property, so what 2 different properties did we put in here this time? Negative exponent and 0 exponent property. So we threw both those into that one. All right, last one we're going to do. Oh, actually 2 last ones. I did say 2, didn't I? What about this one? These are you're going to get a couple of these on your test. So I actually got 3. How about this one? 4g in parentheses to negative 3rd power. Really good one to do right here. What do we do first? You can take the reciprocal right now. Yes. Yep. We have 2 options here. You can use the power of a quotient property first and take, or not power of a quotient, but power of a product property, and raise 4 to the what? And g to the what? And then take the reciprocal of those. Okay, or as Bailey said, take the reciprocal of 4g right now. What's the reciprocal of 4g?
1 over 4g.
Yep, so we could go ahead and take the reciprocal of 4g right now, which is 1 over 4g in parentheses, but raised to what power now? To the positive 3rd power, exactly. Now we have to simplify and raise 4g and g to the 3rd power. So 1 over, what's 4 to the third? Obviously it becomes 4 to the third times what?
G to the third.
G to the third. Now, you don't really have to have this step if you don't want it. You can go ahead and go right into, what is 4 to the third become? 60 what?
4.
4, G to the
Third.
third, right, okay? You could have done that, or you could have done it the other way. You could have taken 4 to the negative third power, times G to the negative third power, and because they're both negative exponents, where do you put them? Because couldn't they be over 1? So would that mean you have to take the reciprocal of that, which would become what? 1 over 4 to the third times G to the third, and do you get the same answer either way I did it? Okay, so again, there is that open to interpretation in terms of which way do you want to do the problem. Do you want to take the negative exponent property first? Or do you want to go ahead and use the power of a product first and then take the negative exponent property? It does not make a difference. You can come at it different ways. All right, next one. How do I do this one? X to the second times y to the negative fifth. How do I simplify that? What could I put that whole expression over?
1.
Over 1. Tell me right now, what stays in the numerator the way it's at?
X.
The x to the second, right? Why does it stay? Because it has a what exponent?
Positive.
Positive. What doesn't stay where it's at?
Y.
The negative fifth. Where does that one go? To the bottom. What's my final answer going to be? X squared over
Y.
y to the fifth. Those are huge, guys. Knowing how to do, they're going to have some practice tonight on the practice worksheet to do those. Okay? I got one more, but I think I'm going to stop because we have just a few minutes for it to go. So I want to stop here. We have plenty of